In this video, we'll just continue discussing the exponential function. This time we will deal with uh, natural exponential function, which is a special case of exponential function. Remember, we have two cases for exponential function. The first case will be if b is greater than 1. So this case will be considered here in this discussion. Now first, let's define the number e. So this one is not a variable, this is a constant. Okay, the number e is called the natural number and is defined as the number that the expression, this one, as n increases without bound. So imagine if n, this n here, right here, increases without bound. So n can be 1, n can be 2, n can be 3, or with decimal, okay, 3.5, 3.5, and so on, increases without bound. If that would be the case, if n increases without bound, this expression right here, the answer for this, also approaches to that number which is called e, and it turns out that this number is equal to 2.71828 and so on. So it's just like, this one is just like the pi that we have learned in our elementary years. Now, this expression, the answer for this, approaches to e, which is this one, as n increases without bound. Now, let's define the natural exponential function. Now, this natural exponential function is just a special case of our exponential function where b is greater than 1. Okay, because we've already knew that e here is greater than 1, right? Because that's 2.71, that's greater than 1. So meaning we're considering that the case that is b is greater than 1. The function defined by, so the natural exponential function is a function, is the function f defined by f of x equals e raised to x. And e, remember, is a constant, not a variable. Okay, so this e is this number, is called the natural exponential function. So if the function f is defined by this equation, then that function is called natural exponential function. The rational number, irrational number e, just like your pi, is called the natural base. Okay, so e is called the natural base, where e here is this value. So it goes on and on and on without so far a certain pattern. Okay, now the domain of this function f defined by this, or our natural exponential function, the domain is the set of all real numbers. So you can pick, just like our exponential function, the domain is set of all real numbers, while the range is, yes, the same. The range is from, not including 0, from 0, between 0 to infinity. Again, this one, it does not include 0, okay? So how does this function f defined by this looks like? Now we can look at this one using our calculator. And just delete all of this. So let's try e. Okay, e raised to x. So how does it look like? So it looks like this. As you can see, it is increasing. So just like any exponential function whose b is greater than 1, so it looks like this. This is the graph of our f of x of f, which is defined by f of x equals e raised to x. So a little bit steeper, right? It's okay. Again, our x is our horizontal asymptote. Uh, the y-intercept here is 1, because if your x is 0, then your that's e, so that's 1. Okay, so the graph of the function f defined by this, or our natural exponential function, looks like this. Okay, the domain of that function is the set of all real numbers. In other words, the domain, you can pick any x here as our value of x for this function, and the range is this interval. So it starts from here, not including 0. Okay, it does not include 0. It goes to infinity. So this is the range. As you can see, the graph starts from, but not includes here. Okay, so it goes up. That's the range. Okay, it does not include 0. Okay, so that's the this is the graph. So this is just a special case of our exponential function. We give special attention to this case because it naturally, or it is common in higher mathematics that we deal with this so-called natural exponential function. Okay, so that's the graph. Now let's try to sketch the graph of each function defined by number 1, f of x equals e raised to negative x. So as you can see, the 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 x here is negative. All right, so if x is negative, we've already knew that the graph of f defined by f of x equals e raised to x is this one. So what happens now if this becomes negative? That's the question. So for example, if your x is 1, so it means if your x is 1, so here it becomes negative 1. So this is now the corresponding. So the value for 1 is now here. Okay. For negative, for 2, this becomes negative 2. All right. So the value here corresponds now here. So what happens is that this is just a reflection of our, so the graph of this f defined by this is just a reflection of this with respect to y-axis. So the graph now is so the graph of f defined by this is if this is the graph of f defined by f of x equals e raised to x. Now the graph of f of x e raised to negative x is just a reflection with respect to y-axis, so it looks like this. So this is our y-axis. Okay, so the graph now looks like this. So Okay, so this is now the graph of our f defined by this. Okay, so the same shape but of different orientation. This is just a reflection of our e raised to x, which looks like this with respect to our y-axis. How about number 2? For number 2, f of x, now f here now is defined by f of x equals negative e raised to x. So for that, if this is the graph of our f of x equals e raised to x, what happens now if we put negative? So meaning the value which is e raised to x, okay, if we put negative, so that means the value now is in here, in the opposite side of our y-axis. So that becomes, so now the value of this will now be here. So for the corresponding point x, so this becomes right here, corresponds here. So which means for any x, we have a corresponding negative value. Okay, so now this is now the reflection. So the graph now of this negative e raised to x is just a reflection of our this one of e raised to x with respect to x-axis. Why? We can make, or we can show, okay, by giving you sample points. Okay, so let's say okay, so remember the graph of our f of x equals e raised to x looks like this, right? So what's the appearance if your f of x is negative e raised to x? Okay, again, the graph of e of x looks like this. Now how about for the f that is defined by this? So we've already knew that the for any x, okay, we have a corresponding e of x. Now if this becomes negative, so the corresponding point now is here in the opposite side of our y-axis. So this becomes here, this becomes negative ex. So the corresponding point now is here. Now for here, we have the corresponding point here. So intuitively, this is just a reflection of our e of our e raised to x with respect to the x-axis. So the graph now for number 2 is okay. So this is now the graph of f defined by this. That's f. So this is f. So that would be all for the natural exponential function. So thank you very much for listening and have a nice day.